Chapter 3.4, Day 1, Solving Multi-Step Inequalities. You can use the properties of inequalities to solve multi-step inequalities, the same way you use the properties of equality to solve multi-step equations. Example number 1, solving multi-step inequalities. So in example number 1, we have y over negative 6 plus 7 less than 9. So you want to find the y, or you want to have the y by itself, so you're going to remove the 7. So you're going to subtract 7 on both sides. Y over negative 6 is less than 2. Now to isolate this y, you're going to remove the negative 6 from the division. So opposite operation of division is multiply negative 6 on both sides. Remember, when we multiply with negative number, we need to switch the inequality and y is greater than negative 12. To graph this, I made a number line, so I skipped some number in between. I have a negative 12 here. Since this is a greater than sign, it doesn't have an equal underneath. So the graph of this is going to be an open circle. And since y is greater than, so it's going to go to the greater side of the number line. Now for number 1, you're going to add 1 on both sides. So you get 4b less than 8. You're going to divide with 4 on both sides to get b by itself. And in this case, you're only dividing with the positive number, so there is no change in inequality. Number line is easy for this one because it's just 2. On top of 2, you're going to make an open circle, and since b is less than, so it's going to go to the negative side of number line. Now let's discuss number 2. So to find c by itself, you're going to subtract 8 on both sides first. So when you subtract 8 on both sides, you get 9c greater than or equal to negative 36. Divide 9 both sides, you get c greater than or equal to negative 4. You make a number line, and on top of negative 4, you get closed circle. So since c is greater than, so it's going to go to the greater side. For number 3, you're going to subtract 11 on both sides. You get n divided by negative 2 greater than 1. To remove this negative 2, you're going to multiply with negative 2 on both sides. Whenever you multiply with negative 2, you're going to switch the inequality, so n is less than negative 2. On top of negative 2, you make an open circle and it's going to the negative side. When solving an inequality, if you obtain an inequality that is true, such as negative 5 less than 0. 3.4, example number 2, solving an inequality with no solution. So you're going to solve the inequality the same way you solve equations. So which means that you're going to distribute the 4 inside. So you're going to get 8x minus 3 greater than 8x plus 12. We want to have the variables on one side and the numbers on the other side. So my next step is going to be 8x, subtract 8x on both sides. In this case, I get negative 3 greater than 12. Negative 3 is not greater than 12, so it means that we say that this is false, and whenever we say false, it means there is no solution for this inequality. Example number 3, solving an inequality with infinite many solutions. To solve this inequality, we're going to distribute the 2 inside first, and which graph represents the solution. So we're going to choose which graph is the solution of this inequality. So first of all, we're going to solve this inequality. So you have 2 times 5x minus 1 less than or equal to 7 plus 10x. Distribute the 2 inside, you get 10x minus 2 less than or equal 7 plus 10x. Subtract 10x on both sides. What you get is negative 2 less than or equal to 7. Now this inequality is true because -2 is less than 7. If it is true, it means that you have infinite many solutions, or you write all real numbers. So when you write all real numbers, it means all the solutions in the real number line. So all the solution in real number line is B, that is this line right here. Now you're going to pause the video and try number 4 and 5. For number 4, you're going to distribute the 2 inside. So you get 2 times k is 2k. 2 times -5 is -10, less than 2k plus 5. Now you're going to bring the variable on one side and numbers on the other side. And my first operation to do that is subtract 2k on both sides. So to 2k and 2k cancel, you get -10 less than 5. -10 is actually less than 5, so its inequality is true. So which means that has infinite many solution or all real numbers. It means that the graph of this inequality would look like something like that, which will cover all the real numbers on real number line. For number 5, you're going to distribute -4 inside. So -4 times 3 is -12n. -4 times -1 is +4. Plus 12 on both sides. You cancel the 12 from both sides. 4 is greater than 5.2. Since 4 is not greater than 5.2, so it means this inequality is false. So it means there is no solution. Example number 4, real life application. You need a mean score of at least 90 to advance to the second round of the trivia game. What score do you need on the fifth game to advance? Use the definition of mean to write and solve an inequality. Let x be the score of the fifth game. So there are 4 games given to you. So the game number 1 you have 95 scored. On 2 you scored 91. For number 3 you scored 77. And for number 4 you scored 89. Mean definition is add all the terms divided by number of terms. So the definition of mean is add all the terms divided by number of terms. It will give you the average mean. So now we are going to add all the 4 games, and the fifth one we assume that is x. So our equation is going to look like add 95 plus 91 plus 77 plus 89 plus x divided by number of terms that are 5, and average score or mean score is given as 90. When you add all the terms on the top, you're going to get 352 plus x divided by 5 equals 90. Now you're going to remove the 5. So we're going to multiply both sides by 5 so that we can cancel the 5 from the bottom. So you get 352 plus x equals 450. Subtract 352 on both sides, you get x equals 98, which means that you have to score 98 in the fifth game in order to have the mean as 90.